Okay, so the question says how many numbers up to 493 are divisible by 17? See, since the 17 is a prime number, so just to know how many numbers are divisible by 17, we can simply do this by dividing 493 by 17, because 17 number has got no other multiple then only then no other divisor than the 17 and 1 itself, and it is a prime number. So this question can be easily answered by dividing 493 by 17. 17, which comes out to be, this case the quotient value is only to be taken. The quotient value comes out to be 29. Obviously 493 is not completely, 29 is the quotient value. So 29 are the number of numbers up to 493 which are divisible by 17. So answer is option number C. Now, in the second one, he says A, B, C, D, E, F be six distinct positive real numbers such that A is to B is equal to C is to D is equal to E is to F is equal to 2 is to 3. Okay, in this situation, he wants 3E minus 4 divided by 3F minus 6 can never be equal to the expression given in the options. So what we can do is, as the numbers are not mentioned, but their connection, but their ratios are mentioned like this. They say A by B is equal to C by D is equal to E by F is equal to all, everything is just equal. Now, so we can relate these numbers. So if we compare A by B is equal to 2 by 3 like this, A by B is equal to 2 by 3, then clearly we can come across a result that 3A is equal to 2B. So this is the first result, 3A is equal to 2B. Okay, this can be stated as equation number 1. Similarly, if we equate C by D is equal to 2 by 3 like this, C by D is equal to 2 by 3, then we can again reach to the result that 3C is equal to 2D and things like that. So next result is coming out to be 3C is equal to 2D. That is the equation number 2. Similarly, if we equate E by F to 2 by 3, we can again result the similar kind of a result, that is 3 is equal to twice of F. So these are the three equations we can form using the ratios. Now, what we are supposed to do, he is asking for the value of 3e minus 4 upon 3f minus 6. Clearly, we'll have to assume any distinct numbers of a, b, c, d, and then try to verify that that particular set of values of a, b, c, d, e, f, whether the solution of this 3e minus 4 of 3f minus 6 is coming equal to either a or b or c or d, and whichever it is not coming equal to, that should be our right answer. Okay, so let us just assume, okay, let's say a is equal to 4. We are supposed to assume any six distinct positive real numbers, so we can assume anything, but they should be different. So let us say a is equal to 4. So if we use equation number 1, this will give us b is equal to, see, 3a is equal to 4, so 3 4s are 12, so b is equal to 6. This will come. Similarly, if we assume, let say c is equal to 8, so from equation number 2 we can easily find out if c is equal to 8, then 3c is 24, 24 is equal to 2d, that means d is equal to 24 by 2, that is 12. Similarly, if we assume in the third case e, let us assume, let's say e is equal to 16. If we do that, then from this equation what is f value can be equated as 3 into 16 is going to be 48, divided by 2 is going to be 24. So there where we can find out f value as 24. So there is one set that is available with us. A, B, C, D, E, F value is all there. Every value is positive and distinct. Now with this set of values, we'll try to verify the answer of 3e minus 4 over 3f minus 6 out of all the options available. So if you want to put all these values into the expression required, that is 3e minus 4, e value is 16, so it's going to be 3 into 16 minus 4 divided by 3f minus 16, that is 3 into f value is 24 minus 6. If we solve this, this is going to be 48 minus 4 divided by 72 minus 6, which is nothing but equal to 44 by 66, which is nothing but 4 by 6, or again coming equal to 2 by 3. So that is the answer of this expression is coming with one set of a to f values taken assumed. Okay, he's asking for which of these option does not match with the same set of value as 2 by 3. So we can try one by one. We can try for A, we can try for B, we can try for C, we can try for D. If we try for D, let's see what is the value coming. Okay, let us try for D. The option B has got 3C plus 4A plus 2 divided by 3B plus 4D plus 3. Let us put our values that are there. That is equal to 3 into 8 plus 4 into 4 plus 2 divided by 3b. B value is b value is come out to be 6. 3 into 6 plus 4 into d. D value is 12. 4 into 12 and plus 3. That is the ultimate expression of the option number 4. If we try this, how much is coming? 8 3 are 24 plus 4 4 are 16 plus 2 divided by 6 3 are 18 plus 12 4 are 48 plus 3, that is this, which is coming as 24 plus 16 40 plus 2 42 divided by 48 plus 18 is 66 plus 3. 48 plus 12 is 60 plus 6 is 66 plus 3 is going to be 69. If we try to cut this, then we can cut this using 3. So we can cut this using 3. So we can cut this using 3. So it's coming out to be 14 divided by uh, 23. 14 divided by 23, which is not at all equal to 2 by 3. But if you try option A, B, and C, every time the answer is coming out to be 2 by 3 only for this set of value. So this option number D can never be equal to the value. Option number D can never be equal to the expression given here. So that is our right answer, option number D. Now, the next one is the sum of squares of three consecutive natural numbers is 2030. The second number is sum of the squares of three consecutive natural numbers. So let us assume the first number, let the number is x. Then the consecutive natural number will be one ahead of it. So it's going to be x, then x plus 1. Then the third consecutive natural number will be x plus 2. So they are in a gap of 1, 1. So these are the three consecutive natural numbers. He's saying sum of squares. So we need to do the squares and then add them. X square plus x plus 1 whole square plus x plus 2 whole square. This is the sum of square and saying is equal to 2030. So let us try to solve this. This is x square. We can open x plus 1 whole square by x square, a square plus b square plus 2ab formula. So it's going to be x square plus 1 square plus 2 into x. Similarly, this can be again opened by the same formula. It's going to be x square plus 4 plus 2 into x, that is 4x is equal to 2030. Clearly, we can solve this expression, x square plus x square plus x square. So it becomes 3x square plus 2x plus 4x is becoming equal to 6x plus 1 plus 4 is equal to 5 is equal to 2030. We can create an equation out of it, which is coming as 3x square plus 6x minus 2025 is equal to 0. If we take 3 common from all the thing, it's going to be x square plus 2x minus 675 equal to 0. Now, this is what is the equation that we have, and we are supposed to solve x for this. There can be multiple ways of doing that. We can apply Sridharacharya also, or we can do it by prime factorization also. Okay. So if we do the factors of this particular equation using any of the method, this can be broken down as x plus 27 into x minus 25 equal to 0. There where the two values of x is coming as minus 27 and 25. Obviously, minus 25, 27 cannot be taken because the number have to be natural number. Natural numbers are not negative. So clearly the x value to be taken in this case is 25. What he had asked for? The second number. So the second number was nothing but x plus 1. So 25 plus 1, 26 is our answer. That was our second number. It's available in option number C and becomes the right answer for us. Now, the greatest among the following numbers 3 to the power 1 by 3, 2 to the power 1 by 2, 1 and 6 to the power 1 by 6 is. We are supposed to find out greatest among the following numbers. Okay, so let us try to see the numbers. If we have to find them, the greatest or greatest or least out of them, we need to make them looking like a similar number so that we can compare without having to solve. So what we can do out of these, we have got the numbers as 3 to the power 1 by 3, then 2 to the power 1 by 2, then 1, then 6 to the power 1 by 6. Okay, these are the numbers. Let us see the LCM. LCM of 3. What is the LCM of 3, 2, 1 and 6 is? That is nothing but 6. So every number can be represented in the form of 6. How we can do that? See, the first number 3 to the power 1 by 3 can be written as 3 into 2 by 6, because 2 by 6 will get cancelled to 1 by 3 only. So we are not changing the number. We are just manipulating. Next number can also be written in the form of LCM as 6. So it can be 3 by 6. Okay. The next number can be written as the 1's power. So 1 can be just written like that, 1 only. 1 can be written as 6 by 6. And the last number can be written as 6 to the power 1 by 6. That is nothing but 6 to the power 1 by 6 can be written as it is 6 to the power 1 by 6. Now what we have done, we have made the powers of all denominators of the power, all powers as same. Now what we can do in this one is 3. Now this 3 to the power 2 by 6 can be manipulated as 3 square to the power 1 by 6. Next number can be written as 2 cube to the power 1 by 6. Next number can be written as 1 to the power 6 to the power 1 by 6. and the last number can be written as 6 to the power 1 to the power 1 by 6. Now what we have done in this case is we have taken the numerator in the inside value. So what are the values becoming? This is becoming 9 to the power 1 by 6. Another number becoming 2 cube is 8 to the power 1 by 6. Next number is 1 to the power 1 by 6, and the last number becomes 6 to the power 1 by 6. Now the numbers are same, their orientation have been changed every time the power is same. So whichever number is having the largest magnitude, that will be the largest number. He's asked for the greatest number, so greatest number is simply going to be 9 1 by 6, which was earlier 3 square 1 by 6, and which was earlier 3 to the power 1 by 3. So the greatest number is 3 to the power 1 by 3. This is how we can find out. So there the option available is option number C and becomes the right answer. Okay, so the question says a number consists of two digits. If the digits interchange their places and the new number is added to the original number, then the resulting number will be divisible by what? So we are supposed to here assume the digits first. Okay, so any two-digit number has got two digits. First digit is called as a unit digit, that is the rightmost one, and the left one is called as the 10th digit. Okay, so in this case, he's saying a number consists of two digits if the digits interchange places. So first of all, we'll have to assume the digits. So let's say the 10th digit, let's say the 10th digit of a number is x, and let's say unit digit, that digit at the extreme right, unit digit is, let's say, y. So when the 10th digit is x and unit digit is y, how can we make the number? So we can write the original number. Original number can be made by 10 into the 10 digit plus the unit digit as it is. This is how the number can be made, okay, which comes out to be 10x plus y. So this is our original number, 10x plus y. Then he says if the digits are interchanged, that means the unit digit and 10 digit are changed. So the unit digit now becomes x, and 10 digit now becomes y. So the new number will be now, new number will be, the number can always be made by 10 times the 10 digits. So it's going to be 10y plus the unit digit. So it's going to be x. So this is what the new number is, 10y plus x. The old number or the original number was 10x plus y. Now what is the connection between these two numbers is given? They are saying that if the digits interchange places, the new number is added to the original number, then the resulting number will be divisible by what? So we are supposed to add these new number plus original number, that will be 10x plus y plus 10y plus x. If we add together, this comes out to be 11x plus 11y. We can obviously take 11 as common from both the numbers, so it's going to be 11x plus y. Now they're asking for the resulting number will be divisible by what? So it is clearly seen that this is a multiple of 11. So the resultant number is divisible by 11 only. So answer is option number A. Now, if 3/4 of a number is subtracted from the number, the value so obtained is 163. Which among the following is that number? So in this case, we can assume the number to be x, then apply the condition that is given already there and make an equation out of it, and then solve that equation for x. So let us begin the question by assuming that let the number be x. Let that number that is required is x. Then he's saying if 3/4 of a number is subtracted from the number, that means number minus 3/4 of the number. He's saying when you subtract like this, the value so obtained is 160. So it will be equal to 163. So let us put in place of number, we can put as x. X minus 3/4 of x, they are saying it to be 163. If we solve this, how much this becomes? This is 4x minus 3x, that is x by 4 is 163, which calculates the x to be 163 into 4, that is nothing but 652. So 652 is the number that was required in the question, and it is available in option number D and becomes the right answer. Now, the following addition is incorrect. There is an addition situation given here. This can be made correct by changing one digit D. So this can be corrected by just changing one digit D wherever it occurs. So it can be found out anywhere and with another digit E. So the digit D is to be replaced by digit E. Then they are asking for what will be D plus E. So clearly we are supposed to verify, we are supposed to investigate this particular expression and find out where is the error coming, and from there only by trial and error method we will be able to find out that wrong digit. Okay, so let us try to add these numbers. So 6 plus 0 is 6 plus 6 is 12. Rather, the first line is 742586. Next line is 829430, and the addition value that is given is 6, then 1 here, then 0 here, then 2 here, then 1 here, then 2 here, and then 1 here. If you add them, let us find out. 6 plus 0 is 6, so 6 is there, so this is correct. Then 8 plus 3 is 11. 11, for 11, we will write down 1 here, and there will be a carry generated 1. So then 1 plus 5 is 6. 6 plus 4 is 10. So for 10, we'll write 0 here, and another carry will be generated here. Now 1 plus 2 is 3. 3 plus 9 is 12. So a 2 will come down for 12 here, and another carry is being generated here. So till here, there is no problem. Now if we add it further, 1 plus 4 is 5, 5 plus 2 is 7, but there is a 1 here. So there can be the problem. So we need to verify where comes the problem so that we can actually change the digit and we can get to the right one. Okay, so by investigating and by keep and trying once again, we can actually see that if particular digit 2 is replaced as 6, if the particular digit 2 is replaced as 6, the equation can come as right. Let us redo it by replacing 2 as 6. Now the new set of number will be 746. In place of this 2, we'll write 6, 746, 586, then 8. Then in place of this 2, we'll write 6, 869, 430, and the sum should come as 6 as it is, 1, 0. In place of this 2 will be a 6 here. This 2 is also replaced. All the 2's have been replaced by 6. All the 2's have been replaced by 6. So it's 6, then it is 1, then it is again a 6, and then it is 1. Let us verify with this. 6 plus 0 is 6, that is fine. 8 plus 3 is 11, 1 is written, and a carry 1 is generated. That 1 plus 5 is 6, 6 plus 4 is 10, 0 is written, and carry 1 is generated. 1 plus 6, 7 plus 9, 16. So 6 is written here, and carry 1 is generated. 1 plus 4, 5 plus 6, 11. A 1 is written here, and a carry of 1 is generated. 1 plus 7, 8 plus 8, 16. So complete 16 is written here. So our guess, our trial and error is right for this case. The digit 2 to be interchanged with 6. So D digit is 2 and E digit is 6. What they ask for? They ask for the value of D plus E. So D plus E is going to be 2 plus 6, that is 8 has the answer. Okay, so the question says Sarah has just joined Facebook. She has 5 friends. Each of her 5 friends has 25 friends. So it's like this. Sarah is here. She has got 5 friends, 1, 2, 3, 4, and 5. 1, 2, 3, 4, and 5. And each of her 5 friends has 25 friends. So each of them has got 25 friends in all, with each of them are there on Facebook itself. Okay. Then he says it is found that at least 2 of Sarah's friends are connected. That means at least 2 of Sarah's friend connected means that there is no friend or the friends of friends who is not connected to anyone. That is, there is no friend who is alone. Every friend is connected to at least one of the friends. Okay, there is no such friend who has got no friend altogether. Okay, so at least one person is there who is connected with at least 2 people. Okay, on her birthday, Sarah decides to invite her friends and her friends. How many people did she invite to her birthday party? So clearly, if she has got 5 friends and each friend has got 25 friends, the total friends are 25 into 5, that is 125 friends are there in all in this network. Now at least 2 friends are there who are having 2 friends at least. So the common friends are at least, the common friends we can count it as common friends are at least 2. Okay, at least 2, that is minimum they are 2. So how many friends he is supposed to invite? So if at all, in the extreme case, we consider that there are 2 such person who have got just one friend only. Okay, if we assume that there are 2 such person who have got one friend only, then these 2% can also be excluded to invite, because if their friends are invited, they must be already getting the invitation. So these 2 people can be left out. For the minimum case, these 2 people can be left out. So how many invitations are required to be sent? It has to be either equal to 123 or less than 123. Invitation needed to be sent are either equal to 123. Maximum 123 invitation will have to be sent, because those 2 people in the minimum case, if you've got just one friends each with them, then also they are not supposed to be invited. So only 123 or less than 123 friends are supposed to get invited. So this particular option is available in option number B, becomes the right answer. Now, the mean of 15 different natural number is 13. The maximum value of second largest of these numbers is, okay, there are 15 different natural numbers, and their mean he's saying is the mean is 13. Okay, so let's say if the mean value, let's say, is 13, and the total number of such numbers are 15. So what is the sum of them? Okay, sum of those 15 numbers will be what? 13 into 15, okay, which is going to be 195. So there are 195 is the sum of all those number altogether. Now he's asking for the maximum value of the second largest number. Okay, so if we look at carefully, then say if there will be a largest number, and then there will be a second largest number, and then there will be 13 such numbers behind second largest number. 13 such numbers will be there in the list behind the second largest number. So if we focus on these 13 numbers, and we'll take the minimum case because he's asking for the maximum value of second largest. So let us take the minimum case. In my minimum case, what is becoming the sum of those 13 numbers? Okay. So for the minimum case, let us take the first number as 1, next number as 2, next number as 3, and so on till 13. So what is the sum they are making? Here we are supposed to use the formula for sum of n natural numbers. That is nothing but sum of n natural number is nothing but n into n plus 1 by 2. If we use this formula, we have got 13 such natural numbers. So sum is coming out to be 13 into 14 divided by 2. That is nothing but 91. Okay, so 91 is the sum of these 13 number for the minimum case. Okay, and the total sum of all those 15 numbers we just calculated to be 195. So what is the value of the largest and the second largest number? Will be simply sum of all 15 numbers minus sum of these 13 numbers, that is equal to 195 minus sum of these 13 numbers is about how much? 91. How much it is equal to? 104. So that is the sum of the largest and the second largest number, 104. Now we are supposed to find out maximum value of the second largest number. So if we take the maximum, if we want to know the maximum value of second largest number, and the sum should be 104, so what should be the combination between these options given, 53, 52, 51, and 50, so that the sum always become 104? So the combination that can be made is only 51 plus 53 is equal to 104. So this is the only combination possible. So that's clearly states that the maximum value of the second largest number can be 51. Well, that is the right answer. Option C is the right answer. Now he says the denominator of a fraction is 3 more than the numerator. If the numerator as well as the denominator is increased by 4, the fraction becomes 4 by 5. In this situation, we can always assume the fraction, or rather we can do that we can assume one of the numerators or the denominator, and then as per the condition decide the denominator. Okay, so let us assume he says denominator of fraction is 3 more than the numerator. So the reference can be made of numerator. Let's say the numerator is x, then clearly the denominator should be how much? The denominator should be, as he says, denominator is of the fraction is 3 more. So it has to be x plus 3. So these are the numerator. This is the denominator. Then he says the numerator as well as the denominator is increased by 4. So what is our fraction right now? The fraction right now is x over x plus 3. That is numerator over denominator. Then he says if the numerator and denominator are increased by 4. So let us increase them. So the new fraction will be numerator is also increased by 4 and the denominator is also increased by 4. If we do like this, then he says the fraction's value becomes 4 by 5. So clearly we have this expression to solve for x. If we do this, this becomes x plus 4 divided by x plus 7 is equal to 4 by 5. Then obviously we can do the cross multiplication, which gives us 5x plus 20 is equal to 4x plus 28. If we solve this further, this gives us the x value as 8. What did he ask for? He asked for the original fraction. So the original fraction that we assumed was this x over x plus 3. If we put the x value, we're going to reach to 8 over 8 plus 3. That is nothing but 8 by 11. So that is the right fraction, original fraction value, 8 by 11. That is available in option number D. Now, starting from 1 as the first odd number, 3 as the second, and so on, find the 300th odd number. What are they asking? Starting from 1 as the first odd number. So 1 should be taken as the first odd number, and 3 should be taken as the second odd number. Okay, this is the first odd number, as we all know. And second also is the third, 3 is the second odd number. Then obviously 5 is the third odd number. In this sequence, he wants us to calculate what will be the 300th odd number. This is the question given to us. So let us follow this pattern itself. First odd number is 1, second odd number is 3, third odd number is 5, and so on. So how many odd numbers are there between 1 and 100? Okay, let us try to find out this. How many odd numbers are there between 1 to 100? There are 50 odd numbers. Okay, so clearly we can say that 100, if 1 to 100 there are 50 odd numbers, then uh, the 100th or the 50th odd number is going to be the 100. What can we say? The 50th odd number is going to be 100. Okay, 1 to 100 there are 50 odd numbers, and 50th odd number will be 100. Similarly, we can say up to, if you want to know up to 1 to 200, 1 to 200, then how many odd numbers are there? It is again 200 divided by 2. Okay, that is nothing but 100. Okay, so how many odd numbers are there between 1 to 200? There are 100 odd numbers. So clearly we can say that 100th odd number is nothing but the 100. So 1 to 200 there are 100 odd numbers. So 100 odd number should be one less than 200, that is 199. Okay, clearly the 50th odd number was not 100. Clearly the 50th odd number was one less than 100, that is 99. This is how it is. So in this pattern, we can extend this further. So uh, if we want to know the 300 odd number, the range has to be, see, if we wanted to know the 50th odd number, the range was 1 to 100. If we wanted to know the 100th odd number, the range was 1 to 200. So if we want to know the 300 odd number, if you want to know the 300 odd number, then the range should be 1 to 600. Okay, the range should be 1 to 600. And what should be the 300 odd number in the same pattern? Should be 1 less than 600, that is nothing but 599. That should be the 300th odd number. Value is 599. Let's see where it is available. It is available in option number B, and becomes the right answer like that. Okay. Now, he says in the next question, there is a 2-digit number with a unit digit being V and the 10-digit being U. Okay, so unit digit is V. So how we calculate the number? The number is calculated by 10 times the 10th digit multi added by the unit digit. This is how the number is calculated. Now, the 10 digit he says is U, and the unit digit he says V. So the number becomes 10 times the 10 digit, that is U, plus 1 time the unit digit, that is V. So this is the number in front of us, that is 10U plus V. Then later he says a new number is formed by reversing the digits. So if the numbers if the digits are reversed, we're going to find out the reverse number. So the unit digit will become the 10 digit, and 10 digit will become the unit digit. So the number will also be swapped. The number now will be 10V plus U. Okay, so this will be the reverse digit number. Then he says if the old and the new number are added together. So let's add. So if the old and new number are to be added, let's add them together. 10U plus V plus 10V plus U. This is how we add it. How much this becomes? This becomes actually 11 U plus V. This is the new number, new result becomes 11U plus B. The resultant number that will always be completely divisible by. So clearly we can see the resultant number is becoming the multiple of 11. So clearly the resultant number is getting divisible by 11. So that becomes the right answer for us. Now, can I have the next question? The question is the product of two consecutive even numbers is 5328. What is the smaller number? Okay, in this type of question, we can assume one number to be x, then another number can be easily formulated as if they are consecutive even numbers. So next even number will be 2 more than the original one, and then we can do their product and make an equation out of it and make it equal to the product that is given as 5328. This is the strategy. So let us assume the first even number is, let's say the first even number is x. Then the next even number, the next consecutive even number will be what? Even numbers are separated by plus 2. So the next even number is x plus 2. Then he says product of these. So let's do the product. Product is multiply x into x plus 2. He's saying the result will be 5328. So this is what the expression has been formed. If you multiply, this is going to be x square plus 2x is equal to 5328. Okay, we can make an equation out of it, a quadratic equation, that is x square minus 2x minus 5328 is equal to 0. This is the quadratic equation. Now we need to break them into factors, or we can use the Sridharacharya as well. If we try to break them, this is going to be x plus 74, because 74 into 72 will give us the product as 5328. So it's being broken down as x into x plus 74 minus 72 into x plus 74, okay, is equal to 0, which gives us x minus 72 and x plus 74 is equal to 0. So these are the two factors of 5328. One is giving the value of 72, another is giving the value of minus 74. Now minus 74 minus 74 and 72 have been taken. So let us take the positive value only, because though there is no option which is in the negative sign, so we'll have to take the positive value only. So the first number has come out to be 72, and the next number should be x plus 2, that is 72 plus 2, that is 74. Then he had asked for the smaller number, so clearly our smaller number is 72. Option number D is right. Now, in a two-digit number, units digit exceeds its tens digit by 2. So we can assume in this type of question also, we can assume any of the digit, and then the relation is given between unit digit and 10 digits, so we can make the 10 digit accordingly. And then using the second condition and using both the digits together, we can frame one more equation and solve it. Okay, this is the strategy. So let us assume, as he say, if a two digit number unit digit exceed the 10 digit by 2, so we can assume the 10 digit first, because that is the reference. Let the 10 digit be x. So the unit digit will be how much? As he say, the unit digit exceed the 10 digit by 2. So the unit digit will be x plus 2. So now what will be the number? Number is always calculated by 10 times the 10th digit plus the unit digit. This is how we form the number. If you do it, it's going to be 10 into the 10 digit, that is 10x plus x plus 2, which is becoming 11x plus 2. So that is the number 11x plus 2. Now, what is the next thing he says? And that the product of the given number and sum of its digits. So we need to find out the sum of digits. Sum of digits is nothing but x plus 2, that is equal to 2x plus 2. So this is the sum of digits, 2x plus 2. Then he's saying product of the number and the sum of digits. So we need to do the product of the number and the sum of digits. If we do the product, it's going to be 2x plus 2 multiplied with 11x plus 2. He says the result should come out to be 144. Okay, so let us solve this equation. This will again become something quadratic. If you multiply this together, we are reaching to 22x square plus 26x plus 4 is equal to 144. Okay, we can take the 2 common and make a simplified equation, that is 11x square plus 13x minus 70 equal to 0. Okay, we need to break them into factor. There is Sridharachara available, or we can do it by prime factorization also. And if it broke down into the factors, this is a product of x minus 2 and 11x plus 35. So these are the two products that has come. Taking the x value as 2, because the unit digit cannot be in fraction. Otherwise, it is coming as minus 35 by 11. That is not possible, because any digit cannot be in fraction. So that only the digit is possible as 2. So our unit digit has come out to 10 digit has come out to be as x as 2. What he had asked for. What is the number? So 10 digit is 2. So the number that was made was 11x plus 2. Putting the value of x in 11x plus 2, we can find out the number, that is 11 into 2 plus 2, that is going to be 24. So that is the number 24 as asked in the question. Now, a test paper consists of 5 questions. 5% of the student who took the test solved all the questions. Okay, 5% did not solve any question. So there are multiple ways we can find out. Okay, zero questions attempted, one question attempted, two question attempted, three attempted, four attempted, and five attempted. We can break down the paper in this fashion. As we give test paper consists of 5 questions, 5% of the student who took the test solved all the questions. So there were 5% of all students that they were which were able to solve all 5 questions, were 5% of the students of the all. Then they say all the question, and 5% did not solve any of the question. That means 0 question was solved by 5% of all the strength. 5% of all the strength had solved no question, so it is going to be 0 here. Of the remaining students, he says the remaining, whatever the remaining students were there, they were able to solve 25% of 25% solved only one question. So one question was solved by 25% of the remaining. Okay, remaining 25% of the remaining. Two questions were solved by, then he says, and 20% solved four questions, and four questions were solved by 20% of the remaining. Okay, 20% of the remaining were able to solve four questions, while 25% solved two questions. So two questions were solved by 25% of the remaining people. So this is the data available with us. So we want to know the what is the number, what percent of the people could solve three questions. That here the percentage is not given, rather the number 216 is given. Okay, so 216 people were there, 216 people were there who could solve three questions. Now what we can do is to find out the total number of questions. What we can do is In terms of percentage, we can find how many how many students were able to solve three question, and then that percentage can be related as the number given to 216. Okay, so let us do it. So what we can do is, now let us find out of the remaining one. Of the remaining one, 25%, 25%, and 20%. This is the data for the remaining one. Okay, so what is the data for this remaining one is is going to be 25% plus 20% plus 25%. Okay, so this is the data of the remaining one that constitutes to 70%. So 70% of the remaining student were there who could solve one question, two question, and four question. Okay, that means the rest of the people other than 70%, how many were there? They were 30%. So 30% of the remaining, because 70% of the remaining were able to solve 1 2 4. So remaining would be 30%. 30% of the remaining would have been able to solve how many questions? Will I have been able to solve three questions? Okay. Now, what is the remaining part? We need to understand what is the remaining part. Remaining part is nothing but all part minus 5% people solved zero question, and also minus 5% the people who solved five questions. That makes it remaining part is nothing but all part is always 100 minus 5 is 10. It's going to be 90%. So 90% is the category of the remaining students, and out of those 90%, 30% of the remaining were able to solve three questions. So we can relate the things like this. 30%, 30 by 100 of the remaining students were 90 by 100. And if we assume our total to be x, so 90 by 100 of x. 30% of the 90% of the student were able to solve three questions, and that number is already given to us as 216. So this is how the percentage data in terms of x has been made equal to the numerical data. Now we need to solve this particular equation to solve for our x. Okay, so if we try to solve this, we can cut down few things like this. Okay, and if we further solve this, this gives us x value to be 216, then 4 times 0 divided by 9 into 3, rather 19 into 30, which can cut down the 0 again. And if you further solve this, this value comes out to be 800 students. So total number of students who were there were 800, and that should be our answer only. It is available in option number B, 800. Now, if a, b are rational numbers and a minus 1 root 2 plus 3 is equal to b root 2 plus a, the value of a plus b is. This is what we are supposed to find out. Okay, so let us first of all write, since a and b are two rational numbers and the expression given to us is a minus 1 root 2 plus 3 is equal to b root 2 plus a. So if a and b are rational numbers, then obviously we can compare the parts with that from both the sides. A minus 1 after bracket root 2 can be compared with b root 2, which clearly gives us a minus 1 equal to b. This is the first connection that we have received. Similarly, these two parts can also be compared as the numbers are real. So it gives us clearly the a value as 3. So if a value is 3, we can put back this into the equation number 1. 3 minus 1 equal to b, so b value comes out to be 2. So we are knowing the value of a and b together. He had asked for what is the value of a plus b, so clearly for a plus b we can add 3 plus 2, that is making it 5. So that should be the right answer. Option number D is the right answer. Now, the sum of three numbers is 68 if the ratio between first and second is 2 is to 3, and that between second and third is 5 is to 3, then find the second number. This is what we are supposed to give. So let us assume our numbers, and then we can find out the ratio between them, and we can make a simplified ratio with all three numbers combined all together. And when the sum is given, so we can add them and make it equal to 68 like that. So let the numbers are a, b, and c, and there's a connection given. A is to b is given out to be rather ratio between first and second, so a is to b is given as 2 is to 3. Similarly, ratio between second and third, so b is to c is given as 5 is to 3. This is what the things are given like. Now, so a is to b is given, b is to c is given. We need to make a combined ratio, a is to b is to c. How we can make the combined ratio? See, if you the letter b is common in both the ratios, the number corresponding to the letter b in the first ratio is 3, and number corresponding to letter b in the second ratio is 5. So what we do is we multiply the a's to b with the 5. If we do that, it becomes like 10 is to 15, and we multiply the ratio 5 is to 3 by the value called as 3. If we do it, this is going to be 3 5 are 15 is to 3 3 are 9. So now this 15 and 15 can be combined because that is same. So it becomes equal to 10 is to 15 is to 9. So that is the combined ratio between A is to B is to C is. Then he said sum of these three numbers is 68. So if the ratio is 10 59, we can make the numbers as 10x, 15x and 9x. So we can make it like this: 10x plus 15x plus 9x. These are the three numbers now is equal to 68. So clearly we can solve for x. X value is 10 plus 15 is 25 plus 9 is 34. 68 divided by 34, that is 2. X value comes out to be 2. We are supposed to find out the second number. What was the second number that we assumed? The second number that we assumed was 15x. Okay, so clearly we need to find the second number as 15x equal to 15 into 2. That is nothing but 30 is the answer. So that is the right answer, which is available in option number A, becomes the right answer for us. Now, in a two-digit number, the digit at the tenth at the units place is more than twice the digit at the tens place by 1. Okay, this is the first thing given. Again, we can start the question by assuming any of the digit, and then the other digit can be related as per the condition given. Then there will be some more condition given which will be able to help us in generating an expression or in an equation, and then we'll be able to try to solve it. Okay, so let us just begin. He says in a two-digit number, the digit at unit place is more than twice the digit at the 10 place. So it will be good if we can assume the 10 place digit, because that can be treated as a reference. So let's say the digit at the tens place is our x. Now he says the digit at the unit place is more than twice the digit at tens place. So unit digit can be written as more than twice the digit at tens place, that is 2x. How much more? By 1. So 2x plus 1. So unit digit can be written as 2x plus 1. So the 10 digit and unit digit both have come. Now we can easily make the number. So the number is always 10 times the tens digit. Tens times the 10 digit plus the unit digit. This is how we can make the number as. So that is going to be 10 into x, that is 10x, plus unit digit is 2x plus 1, which makes it 10x plus 2x plus 1 is nothing but 2 by 1, 2x plus 1. So it is going to be 20, rather 12x plus 1. Okay. Then he says if the digits at the units place and the tens place are interchanged. Okay. So when the digits are interchanged, we're going to get the reverse number. And if the digits are interchanged, this expression particularly reversed. Now 10 times the unit digit now will be 2x plus 1, and 10 digit will be just now x, which gives it 20x plus 2 plus 20x plus uh, 10 plus x, which is nothing but 21x plus 10. That is the reverse digit. He says if the digits are reversed, the difference between the newly formed number and the original number. So let us find out the difference between new number and the original number. If we write it like that, the difference between new number can be the difference between reverse number is 21x plus 10 minus the original number, that is 12x minus 1. This is how we can write. This difference comes out to be 9x plus 9. This is the difference he's saying. The difference, original number is less than the original number by 1. The difference between the newly formed and the original number is less than the original number by 1. This difference is less than the original number by 1. What was the original number? Original number was original number was 12x plus 1. So this particular difference is 1 less than 12x plus 1. So we can write 12x plus 1 minus 1 is equal to this difference. Okay, so it can become like 12x is equal to the difference, which is 9x plus 9. If we solve this, 3x is coming out to be 9. With this, x value comes out to be 3. With x value as 3, we can do anything. He's asking for the original number. Original number we had taken as 12x plus 1. Using the x value as 3, we can find out the original number, that is 12 into 3 plus 1. How much this becomes? This becomes 37. So that is the exact number that we were searching for, the number called as 37. Let's see where it is available. It is available in option number C, becomes the right answer. Now, if the numerator of a fraction is increased by 2 and the denominator is increased by 3, the fraction becomes 7 by 9. So, for this case, we can obviously assume the fraction. Okay, so let's say the fraction is x by y. Then he says numerator of fraction is increased by 2. So, the new fraction becomes how much? Numerator increased by 2 divided by denominator is increased by 3. So y plus 3, x plus 2 and y plus 3. This is what is the new fraction. He says the fraction is equal to 7 by 9. So this is what is being made. Now we can create an expression out of it by using cross multiplication. If we do that, this is going to be 9x plus 18. We are doing the cross multiplication. 9x plus 18 is equal to 7y plus 21, which creates an equation as 9x minus 7y is equal to 3. So this is the expression that is created with us. We can assume that to be equation number 1. Now, let us have the another case. He says, and if both the numerator as well as the denominator are decreased by 1. So let us do it. X by y was the original fraction. Though both are getting decreased by 1. So x minus 1 by minus 1. The fraction becomes 4 by 5. So let us write it as 4 by 5. Let us do the cross multiplication again, which gives us 5x minus 5 is equal to 4y minus 4. Okay, we can create another more equation out of this. 5x minus 4y is equal to minus 4 plus 5 is going to be 1. So this is another equation, that is equation number 2. Now we are supposed to solve these two equations with the help of simultaneous equation method. So clearly we can do that by treating them with some different numbers. So what we can do, let us do it. We can do we either we can make 5 as some multiple of 9, or we can make 7 as some multiple of 9. We can do any other ways. So there could be an easy way. If we could multiply the first equation by 5, that then the 9x will be treated as 45, and the second equation by 9. So this 5x will again become 45, and those two gets cancelled. So if we do like that, we can create one more set and then finding out the subtraction. So how much it becomes? First equation multiplied by 5 becomes 45x minus 35y. And on the left hand side, if we say, and we are subtracting also, the left hand side of the other equation multiplied by 9 becomes minus 45x minus minus becomes plus, so it becomes 36y is equal to, on the right hand side was multiplied by 5 minus on the left hand side it was multiplied by 9, so this becomes like this. 45x and 45x get cancelled. This gives the data of y. So clearly we can get the y's value. Okay, solving this we can get both the values rather. So x value in solving this is coming as 5, y value is coming as 6. Okay, so we can create the original fraction. The x by y was the original fraction, that is nothing but 5 by 6. So that is the right answer. It is available in option number D. Now, a two-digit number exceed the sum of digits of that number by 18. There is a two-digit number which exceeds the sum of its digits. So clearly we'll have to assume the digits first. For that, he has given one condition. Digit at the unit place is double the digit at the 10th place. Okay. So let me assume the 10th place digit, because that can be treated as a reference. Let the 10th digit is x. Then he said unit place is double the 10th place digit. So unit place digit will be how much? Unit digit will be double. So 2x. So these are the two digits available. Let us form the number. Number is always formed by 10 times the 10th digit plus unit digit. This is how the number is always formed. So 10 times the 10 digit is x, 10x plus the unit digit, that is 2x. So the number becomes like 12x. Okay, so the number becomes like 10x plus 2x, that is 12x. Now this is the number. Then he said a two-digit number exceed the sum of its digits. So let us find out the sum of the digits. Sum of the digits is going to be x plus 2x, that is nothing but 3x. So this is the sum of the digits. This is the number itself. He says that sum exceeds the sum, the two-digit number exceeds the sum by 18. So that means the difference of them is 18. So clearly we can write 12x minus 3x is going to be 18, which gives us 9x as 18, which gives us x value as 2. Using the x value as 2, what we are supposed to do is asking for find the number. Number was nothing but 12x. So the number simply becomes 10 into 10, 12 into 2, that is nothing but 24 is the number that they were looking for. Option number D is right answer. Now, an army general arranges his soldier in such a way that the number of rows is the same as the number of columns. In doing so, he finds that 100 soldiers are left out. Okay, if the total number of soldiers are 14,500, the number of soldiers in each row will be, okay, so the total number of soldiers that are available are 14,500. He says if he tries to arrange them in such a way that the number of rows is equal to number of columns, then clearly row into column will be the total number of soldiers that is available. And if he tries to do this, then he's finding that 100 soldiers are left out. So that whatever is the number of soldiers there, plus 100. This is how the situation is. So out of those 14,500, 100 soldiers are getting left out. So how many soldiers are there being easily arranged in the form of row and column is nothing but 14,500 minus 100. That is 14,400. So these many soldiers are completely getting arranged in the form of row into column. Now, so we can write like R into C is going to be 14,400. He said the number of rows equal to number of columns. So we can write for C also we can write as R. So it can be R square is equal to 14,400, which gives the R value as under root of 14,400, which is nothing but 120. So clearly the number of rows that are there are 120. He asked number of soldier in each row because the number of column is also equal to number of row, and the column is nothing but the number of students only. So the number of students, number of soldiers in each row will be also equal to 120. So this is what is the answer. Answer is available in option number B, 120. Now, in a pair of fractions, fraction A is twice the fraction B, and the product of two fraction is 2 by 25. Then the fraction A is. So as the conditions are given, so we'll have to assume one of the fractions and then other fraction can be related. He says fraction A is twice the fraction B. So we'll have to assume the fraction B because that can be treated as the reference. Let the fraction B is nothing but X. Then what will be the fraction A? But the fraction A is twice the fraction B. So it's going to be 2X. Then you say product of these two fractions is 2 by 25. Let's do the product. 2x multiplied by x, he says, is becoming equal to 2 by 25, which becomes 2x square is equal to 2 by 25. 2 and 2 gets cancelled. So x square is equal to 1 by 25, which clearly gives x value as 1 by 5. So what was our x? X was nothing but fraction b. So what should be the next fraction? He asked for the fraction a's value. Fraction a was 2x, that is double of the fraction b. So it has to be 2 by 5. Let us see where it is available. This 2 by 5 is available in option number B. So it becomes right here. On dividing a number by 4, the remainder is 2. The quotient so obtained when divided by 5 leaves the remainder 3. So the data is going sequentially. When any number was divided by 4, the remainder became 2. And whatever was the quotient of this division, when that quotient was divided by 5, the remainder then came out to be 3. And of the second division, when the second division's quotient was divided by divided by 6, the remainder was 5. This is how the data has been given. Okay, the last quotient is 7. The last quotient, that is last puzzle solved, last line solved, is the quotient is 7. So we'll start from the last side only because there is some data given. Okay, as they say, the last quotient value is 7. He said when the number is divided by 6, and this last quotient, what has happened in the last division is the number has been divided by 6 and the remainder is left out as 5. So whatever was the number that was divided by 6, so any number, if we can use the we can use the divisible theorem, that is the number can be found out as quotient into divisor, quotient into divisor plus remainder. This is what is called as remainder theorem. Number can be found out, or number can be also written as dividend. Dividend can be found out by quotient to divisor plus remainder. Okay, so what is that number? So he said this particular quotient of 7 has been achieved when the number was divided by 6. So in place of quotient, we will write 7 and the number was divided by 6. So divisor becomes 6. So the number will become how much? This last number. The last number will become what? 7 into 6 plus remainder. How much was the remainder in the last division? Was 5. So what is this number becomes? 7 6 or 42 plus 5 is 47. So this last number that has been done is 47. Now, in the earlier step, what he had done, he said quotient is 47. Quotient was 47 when the number was divided by 5 and the remainder is 3. That happened in the second line. The quotient so obtained was divided by 5 leaves the remainder 3. Now the quotient is 47. So the second last number, we are achieving the second last number on the middle number. Quotient has to be used as 47. Divisor has to be used as 5. So it has to be 47 into 5 plus 3, and which comes out to be 238. Now this 238 was nothing but the quotient of the first division. Okay, this 238 is nothing but the quotient of the first division. What happened in the first division? Quotient was 238 and the number was divided by 4, and the remainder that was achieved was nothing but 2. So again, we can again create the number of the first step, that is nothing but quotient into divisor. The first number we are achieving, quotient now used will be 238, divisor will be used by is 4, plus the remainder will be used as 2. If we solve this, this comes out to be 954. So the ultimate first step number was nothing but 954, and that is available in option number B and becomes the right answer for us. Now, question number 24. Thrice the square of a natural number is decreased by 4 times the number is equal to 50 more than that the number. So in this type of question, when everything is just getting connected to the number, we'll have to assume the number only. Let the number is x. Now, the first thing is thrice the square of a natural number. So that means thrice the square is 3x square. The natural number is decreased by, he says decreased by, decreased by is subtracted. That is minus sign by 4 times the number. 4 times the number is nothing but 4x is equal to, so then we'll form the equal to sign, 50 more than, that is 50 added to then the number, so that is x. So this is how we can generate expression out of it, and then we can make this in a proper equation form and then solve. It becomes like 3x square minus 4x minus x, that is minus 5x minus 50 is equal to 0. That is what the equation we have. Now this equation can be solved by multiple ways, by using Shidrachara also, or by doing the prime factorization also. If you do the prime factorization or anything, this is how the equation will be broken down into 3x plus 10 and x minus 5 is equal to 0. Solving this, one number is coming as x equal to minus 10 by 3, another set is coming as x equal to 5. Obviously minus 10 by 3 cannot be taken, because he has said the numbers are natural. Minus 10 by 3 is not a natural number. So clearly the x value comes out to be 5, and that is available in option number C becomes the right answer. Now, consider the following statements. If n is a prime number greater than 5, then n to the power 4 minus 1 is divisible by 2400. And second statement says every square number is of the form of 5n or 5n minus 1 or 5n plus 1, where n is a whole number. Which of the above statement is or are correct? So clearly we need to verify whether the statements are correct or not. So let us verify the first statement. He says then if a prime n is a prime number greater than 5, n is a greater than 5 and a prime number, then n to the power 4 minus 1 is always divisible by 2400. This is what is the statement to verify is. So let us start doing by trial and error. So just greater than 5, the first prime number we can take as 7, then we can take as 11, we can take as 13 and so on. Okay, so let us take for 7. If we put the n equal to 7 here, it becomes like 7 to the power 4 minus 1, which is nothing but 2401 minus 1, which is nothing but 2400 itself, and 2400 is completely divisible by 2400. So for the first case, the statement is verified. Let us to take the second case using n equal to 11. How much it becomes? 11 to the power 4 minus 1. How much is 11 to the power 4 minus 1? It is going to be 14,641 minus 1. Okay, if we divide with which comes 14,640, if we divide this number by 2400, yes, it is completely getting divisible. So it is, the test is passed for, the statement is passed for the number called a divisor called as 11 also. Similarly, if we do for 13 to the power 4 minus 1, the number is still passed. So clearly we can say we have tried many prime numbers more than 5, and this test is completely getting passed. So clearly we can say the first statement is correct. Okay, the first statement is completely verified. Let us take for the second statement. Second statement is every square number is in the form of 5n, 5n minus 1 or 5n plus 1. That it has to be 5n, 5n minus 1 and 5n plus 1. Every perfect square lies in any of the form where n being the whole number. So let us begin with the first whole number itself. The first whole number is 0. So if we try, then we have 1, then we have 2, then we have 3, so many. So let us begin with the first whole number, that is 0. If we put 0 in any of them, so if you put in 0 in the first one, it becomes 5 into 0, that is 0 itself. And if we put 0 in the second one, it becomes 5 into 0, that is 0 minus 1, that is minus 1. And if you put in the last one, it becomes 0 plus 1, that is 1. So here 1 is a perfect square. 0 also can be considered as a perfect square, but minus 1 is not a perfect square. So if minus 1 is not a perfect square, that means this statement has been failed. So this is a wrong statement. 5n, the perfect square can not always be in the form of 5n or 5n minus 1 or 5n plus 1. It can be in another form also. So the second statement is not verified. So our answer is going to be only first statement is verified. That is option number A. Then find the value of x if the number 35937x is divisible by both 8 and 3. For doing this question, we need to know the divisibility rules of 8 and 3 both. What are the divisibility rule? Let us find out for 8. Divisibility rule of 8. What is divisibility rule of 8? The divisibility of the rule of 8 is that the last three digits, that is last three digits of the number, should be divisible by 8. That is the divisibility rule of 8. Okay, so last three digit number we have 7, 3 and x, so it is very difficult to verify for this. Okay, so let's take the divisibility for 3. What is the divisibility rule for 3? What is the divisibility rule for 3? Divisibility or rule of 3 is that if sum of the numbers is divisible by 3, let us write that sum of the numbers is divisible by 3, then the number is also divisible by 3. That means we are supposed to add 3 plus 5 plus 9 plus 3 plus 7 plus 3 plus x. That has to be get divisible by completely 3. So we are supposed to judge the numbers, different numbers, which can fulfill both the criteria, this one also and this one also. Okay, so we can go by options also. Let us go by the options. If you put the 8 as an option, 8 in place of x, then the, then the number becomes 738. Let us see whether 738 is getting divisible by 8. 8 9 is 72, carries 1, and then you are left out 18, which is not divisible by 8. So clearly option 8 is wrong. Then if we go by option B, that is 0, the first number becomes 730. If you try to divide that 730 by 8, 8 9 is 72, carry 1, a number becomes 10. That is again not divisible by 8. So option B is also wrong. If you go for option C, the number becomes 734. If you try to divide by 8, that is also not divisible by 8. So clearly all these three numbers have been discarded. Let us try for 6. If the number is 736 and if you try to divide it by 8, yes, 8 9 is 72, then there is 1, 16, 8 to the 16. So it is completely divisible. Quotient coming out to be 92. But this is the divisibility test of just 8. Now we have to verify the divisibility test of 3 also, because he has asked it should be divisible by both. The divisibility test of 3 said the sum of the digits should be divisible by 3. So if in place of x we keep 6, let us see what number it becomes. It becomes 3 plus 5, 8, 8 plus 9, 17, plus 3, 20, 20 plus 7, 27, 27, 27 plus 3 is 30, and 30 plus x. X here is 8, x here is 6, 30 plus 6 is 36. And is 36 divided by 3? Yes, 36 is completely divided by 3. So 6 is that number which can be replaced as x, so that the number that will be completely divisible by both 8 and 3. So the right answer is option number D, 6. Now, the unit digit of 3 to the power 1001 into 7 to the power 1002 into 13 to the power 1003. For doing this question, we need to know the concept of cyclicity. Cyclicity is 3 to the power, if increased like this, 3 square, 3 cube, 3 power 4 and so on, the number that we achieve are 3, 9, 27, 81. If this further is increased, the number is 243. So clearly we can see if it is further increased, the number is 729. So we can clearly see that there is a pattern going on, 3971, 3971 and all that. So we can say the cyclicity of 3 is 4. Okay. Similarly, cyclicity of 7 can be achieved as 7 to the power 1, 7 square, 7 cube, and 7 to the power 4. So if we see the pattern, here will be 7, here will be 49, here will be something ending in 3, that is 243. Here will be something ending 343, there will be something ending in 1. So it will again go like this, 3971. So the cyclicity of 7 is also 4, that is, and the pattern is 7931. So, and again the 3 has come. So what use we'll make of this cyclicity is that we're going to divide the powers that are over every number by 4 only, so that the things become easy for us. For example, so we are trying to find out the last digit or the unit digit of the first number, that is 3 to the power 1001. We can manipulate this number to look like 3 divided by 4 into 250. We have broken down the power with 4 because the cyclicity of 3 was 4. Okay, 4 into 250, then further it can be written as 3 to the power 1. Now every fourth power of 3 ends in 1. So 3 to the power 4 into 250 will have the last digit as just 1. And then 3 to the power 1 will have the last digit as 3. So clearly the last digit or the unit digit, the first exponent is simply 3. Then let us use it for the another one, that is 7 to the power 1002. But 7 has got a cyclicity of 4 as well. So we can again manipulate this number to look like 4 into 250 into 7 to the power 2. Okay, fourth power in of 7 always always ends in 1. So this particular expression will also end in 1, and the next expression that will end in 9. So 1 into 9 will be 9. So last digit of the second expression is going to be 9. Let us see for the third expression, that is 13 to the power 1003. Ultimately 3 is important. So we can break this down into 13 to the power 4 into 250 multiplied by 13 to the power 3. Now any number of the in the power of 3 that of any every fourth power over 3 ends in 1. Okay, so the last digit of this first term is 1, and third power in the cyclicity of 3 ends in 9, in ends in 7 rather, 3971. So last digit of this expression is going to be 7. So this is 7, this is 9, and this is 3. Okay, so this expression can be written as 3 into 9 into 7 for the last digit, which makes it 27 into 7. So last digit is something ending in 7 7 are 49, ending in 9. So clearly the last digit or unit digit of the expression is nothing but 9 becomes the right answer. Next, a two-digit number is three times the sum of its digit, and is if 45 is added to it, the digits are reversed. The what is the number? So we can do this question by assuming the digits first. Okay, let's say the unit digit, let's say the unit digit is y, then the 10 digit should be x. Let us assume it like that. So what should be the number? Number is going to be always 10 times the tens digit plus unit digit. This is how we make the number 10 times the 10 digit plus the unit digit, which is 10 times the 10 digit is x, 10x plus y. So this is the number that we have, original number. He says the sum of its digit is three times the sum of its digits. Okay, so two digit number is three times the sum of its digits. So what is going to be the sum? Sum of digit is nothing but x plus y. So clearly the connection between number and the sum is the number is three times the sum. So 10x plus y is three times the x plus y. That is the first connection that has been made. If we try to frame this, 10x minus 3x is 7x. 7x minus 2y is equal to 0. This is the first equation that we have. Let us look for the second equation, which says sum of its digits, if 45 is added to it, that is 45 is added to the original number. So let us add 45. 10x plus y was the original number. If 45 is added to it, then what happens? The digits are reversed. The digits are reversed. So if the digits are reversed, then the number should become, original number was 10x plus y. The reverse digit number will be 10y plus x. So it should become 10y plus x, like that. We can make another equation out of this, solving which we can get 9x minus 9y is equal to minus 45, which gives x minus y is equal to minus 5. This is the second equation. Now we have got first equation, we have got second equation. We can easily solve them by simultaneous method, multiplying second equation by 2, and then adding it to the first equation. We can easily subtracting it from first equation, we can easily find out the value of y. If we solve together, then the x value is coming out to be 2, and y value is coming out to be 7 for this case. So what we has asked for, what is the number? So the original number was 10x plus y. So the number becomes 10 into 2 plus 7, that is nothing but 27. So that is the right number. 27 is the answer. How he says, n is a whole number which when divided by 4 gives a remainder 3. The remainder when 2n is divided by 4 will be what? So any number can be formed when performed a division can be formed by quotient into divisor plus the remainder. Okay, n is a whole number which when divided by 4. So it can be written as, the number can be written as and the quotient divisor is given to us divided by 4, but the quotient is not given. So we can assume the quotient to be q only. So n can be made by quotient is q into divisor was 4 plus the remainder, that is 3. This is what is remainder theorem is, which makes it 4q plus 3. This is the number. N is equal to 4q plus 3. Then he says the remainder when 2n is divided by 4. So we need to find out 2n first. That is nothing but 2 into 4q, that is 8q plus 6. When this is getting divisible by 4, what is the remainder coming? So let us divide this by 4. 2q plus 6 divided by 4. So we can find out, we can separate this as 8q by 4 plus 6 by 4. Clearly when 8q by 4 will be divided by 4, there will not be any remainder here, because 8 is completely divisible by 4. But on the other side, when 6 will be divided by 4, we will be getting the remainder as 2. So that will be the ultimate remainder of the whole number. The remainder will be 2. Let's see where it is available. It is available in option number B, so that becomes the right answer. Now, which one of the following is not a composite number? Okay, we clearly know that 1 is a number which is not composite, not a prime number. That is an exception, not a prime number. It is not a composite number. Okay, the composite number starts from 4, 6, 8 and like that. The prime number starts from 2, 3, 5, 7 and like that. So which of the following is not a composite number? Clearly 1 is that number, but it's because it's an exception, is not a prime, not a composite number. So that is the answer on the option number A. Okay, so the question says among four consecutive prime numbers that are in ascending order, the product of the first three is 385 and that of the last three is 1001. So clearly there is no pattern between the prime numbers. So we cannot make them like x, x plus 2, x plus 3 and things like that. The prime numbers are random in nature. So there is no pattern between prime numbers. So in this case, if there are four consecutive prime numbers are given, so we'll have to assume each and every prime number as different variable. So let us assume the prime numbers as the first prime number is x, then is y, then is z, and let's say the fourth one is p. So these are the prime numbers that we have assumed, and they are consecutively consecutive prime numbers are in the ascending order. That means x is smallest, y is larger, z is larger than y, and the p is the largest one. Okay, he says the first condition as the product of the first three is 385. So let's take the first three and do the product. X into y into z is given as 385. The next condition he says is that of the last three is 1001. Product of the last three is y into z into p is going to be equal to 1001. So these are the two conditions that are there. What we are supposed to find out the largest given prime number is. So ultimately we have to find out some connection between them. So obviously between these two equations, if we add or subtract, we will not get anything. Rather, if we divide, okay, if we divide, we can get something. It's like x, y, z divided by yzp will give us 385 divided by 1001, which is nothing but 10 over 26. That is 10 over 26 when your y and z gets cancelled on both the sides. So x by p value comes out to be 5 by 30. This is how it is. And this is approximate amount. X by p is coming out to be 5 by 13. So clearly now this is the connection. There is no more connection that has been given, and by using this connection only we are supposed to guess the largest prime number. So there is one way we can do that. We can take the options among them. So the largest prime number which we assume to be was p. By this result we can say that 5p is equal to 13x, which says p is equal to 13 by 5x. Now in this case p has been, the options for p have been given 11, 13, 17 and 19. So let us try something. So if the ratio is x by p is 5 by 13, let us take x as 5 only and p as 13 only. Okay, we have to assume this because the options are given, so we can take them. So if p value is coming as 13, that is the largest number, then x value is coming as 5. So let us try whether we can make such four prime numbers that are starting from 5 and the largest is becoming 13. If you watch it there, this has to be 5 is the first number, 7 the next prime, 11 the next prime, and 13 the largest prime. So these are consecutive prime numbers. So we can clearly say among the option, the largest given prime number is clearly 13. That is option number B is the right answer. Now, determine the face value of 7 in the number. See, face value of any number is exact value of that number. It doesn't depend on where the particular number has been placed, either in the unit digit or in the tens digit. It really doesn't matter. The face value of the number is always remains as it is. So face value of 7 in any number will be just 7. Wheresoever it is found, the face value will always be just 7. So the right answer is option number A. Next, the product of two successive numbers is 6162. Find the larger number. So in this case, what we can do, we are supposed to assume that the first number is x, and he says successive numbers. So the successor of x should be x plus 1. Okay, so these are the two successive number. He says the product of them is 6162. Let's do the product part. X into x plus 1 will give us 6162. Obviously, we can make an equation out of it. Let us try to multiply. This will be x square plus x minus 6162 is equal to 0. So this is what is the equation there in front of us. Now this equation can be held using the Sridharacharya formula also, which says x is equal to minus b plus minus under root b square minus 4ac upon 2a, where in this case our A value is 1 when you compare it with the standard form, B value is also 1 and C value is minus 6162. If we put these value here in this particular formula, then obviously we can get the factors of x. So while we do this, we get the factor of x as x is equal to first value is minus 79 and the another value of x that we get is 78. So these are the two values that we get. He has said product of two successive number is 6162. So clearly we will not be taking the negative number, we'll be taking only the positive number. So x value is 78 is selected. So what should be the larger number? Larger number should be x plus 1, that is 78 plus 1 will be 79. That will be the answer of the question, that is option number D is the right answer. Now, in the next question, he says the taxi charge in a city, including the fixed charges and the additional charges per kilometer. Okay, so whenever your bill is produced, the bill is produced like fixed charges plus additional charges per kilometer. Let us call it as additional, whatever is the additional charge per kilometer, let us call it as rate. Okay, that rate is r rupees per kilometer. Okay, the rate of the additional charge is r rupees per kilometer, and the fixed charges, let us assume the fixed charge to be f rupees. So whatever distance you run, you have to give the fixed charge compulsorily, and then the next condition that is given is the fixed charges for a distance of up to 5 kilometers. So if you run till 5 kilometer only, so then you will have to pay only the fixed charge. But if you run additionally more than 5 kilometers, so as many kilometers you run more than 5, that kilometer value multiplied by the rate will additionally will be have to be paid by you. So bill can be written as fixed charge plus the rate into additional kilometers over 5. As many kilometers you have run over 5, that will be multiplied here in this situation. Now let us see how the bill has been made. The first bill is the charge for a distance of 10 kilometers 350. So bill is of 350 rupees. Fixed charge we don't know, plus rate we don't know, multiplied by they have run for 10 kilometers. So how much is the difference of 10 minus 5 is going to be 5. So this is our first equation. F plus 5R is equal to f plus 5r is equal to 350. This is the first equation of the first bill. Now in the second case, they say for 25 kilometer the bill is 800. So 800 is equal to, we don't know the fixed charge, plus rate value we don't know, into how much additional we have run, that is 25 minus 5. So it becomes, the equation becomes f plus 20r is equal to 800. So this is the second equation that we have made. We are supposed to find out the charge of for a distance of 30 kilometer. For any bill to be produced, we should be knowing the value of f and the rate, the fixed charge and the rate. So by using the simultaneous equation method, we can solve 1 and 2 equations. So let us subtract. Let us do like this: 2 minus 1. Equation 2 minus 1. If we do it, then f and f get cancelled. We are left out with 20r minus 5r on the left hand side is equal to 800 minus 350 on the right hand side, which gives 15r is equal to 800 minus 350 is nothing but 450, which ultimately give r value as 450 by 15, that is nothing but 30 rupees. So the rate has come out to be 30 rupees, that is 30 rupees per kilometer you'll have to pay if you run more than 5 kilometer. Now let's put back this value of r in any of the equation. Let's put this back into equation number 1 so that we can solve for the fixed charge as well. The equation number 1 was f plus 5r is equal to 350. So f plus 5 into 30 is equal to 350, which can come out as f is equal to 350 minus 150, that is 200. So fixed charge has come out to be 200. Now we can generate any bill depending on the kilometers given to us. The bill is to be generated for a distance traveled as 30 kilometer. So for a bill for 30 kilometers can be generated as fixed charge, that is 200, plus additional charge. So additional rate multiplied by additional charge, rate is 30 multiplied by additional charge is 30 minus 5, that is nothing but 200 plus 30 into 25, that is going to be 750, which is nothing but 950. So that is the bill to be produced for 30 kilometer of a distance travel, 950 rupees. It is available in option number D, becomes the right answer. Now let D be a two-digit number if half of D exceeds one third of D by the sum of the digits in D. So clearly we are supposed to make the number. We can solve this equation by assuming the unit digit and the 10 digit, and then we can make the equation, we can make the number using x and y only. Then we can relate the condition given to us and try to generate an equation and then solve for the number itself. Okay, so the number is, let D be the two-digit number. Let's say the unit digit is y. Let's say the 10th digit is x. Let's say the unit digit is y and 10 digit is x. So the number becomes how much? Number becomes always number is 10 into the 10th digit, 10 times the 10 digit plus the unit digit. This is how we make the number. So number becomes 10 into x plus y. That is nothing but 10x plus y. So this is the number that is there. Then he says if half of d, so let us do half of d, that is 10x plus y divided by 2, exceeds one third of d. So that means he is indicating the difference, the half of d and the difference of half of d and one third of d. So let's find out the subtraction sign. One third of d is going to be 10x plus y divided by 3. Half of d and one third of d, there is a subtraction sign being used. How much does it exceed? They exceed by the sum of the digits in d. So sum of the digits in d is nothing but x plus y. So this is what is the expression that we have. We can solve this for x, our x and y, and any connection between x and y. If we do it, let us do it. So this can be solved as 30x plus 3y minus 20x minus 2y is equal to 6x plus 6y. If we solve this further, 4x is equal to 5y comes the value, which gives us x by y value as 4 by 5. So we have got a ratio between the unit digit and 10 digit, but we have not got the number. But we are given options, so we can try something and then we can make the number out of it. Okay, he's asking for the sum of digits. So in this situation, when the options are given, we can let's just take x as the numerator itself, that is 4, and let's just take y as the denominator, that is 5. So now the sum of the digits he's asking for, the sum of digits becomes 4 plus 9, that is exactly 9. So that is the answer only. Option number C, 9 is the answer. If a natural number n leaves the remainder 2 when divided by 3, then the remainder when n cube is divided by 3 will be how much? Okay, this is the question. So he says a natural number n, it leaves the remainder 2 when divided by 3. See, whenever a number when divided by 3, it always, whenever the number uh, is dividing by 3 and it is leaving the remainder, then that is the case when the digits is, when the last digit is equal to 5. Whenever the digit will be equal to 5. See, if we divide 5 by 3, the remainder comes out to be 2. That's what he's pointing at. Whenever a number divided by 3, the result is remainder is 2. If there is one more number, let's take another number, let's say 15. Okay, anything that is ending in 5. Okay, that anything that is ending in, when a natural number n leaves the remainder 2 when divided by 3. So whenever such kind of number will be there, there will be always, we can say, this is the last digit will be equal to 5 only. For example, let's take the example of 25. When we divide 25 by 3, it comes out to be 3, 6 jar 24, and the remainder becomes 1. Okay, so the question says if a natural number n leaves a remainder 2 when divided by 3, then the number when the number n cube is divided by 3, what should be the remainder? Okay, so let us find out the number. We can find out the number using the remainder theorem. Remainder theorem can be brought into the scene. Remainder theorem says the any number or dividend can be made by divisor into quotient plus remainder. This is how any number can be made that is getting divisible by something. So he says the number n can be made like this. Divisor, how, what is the divisor? It is getting divided by 3. So divisor is 3. Quotient we don't know, so we can just write q for that. Plus remainder, the remainder is 2. So this is how the number n can be made. 3 times quotient plus 2. Then he says n cube is divided by 3. So we need to do n cube. For n cube, we need to do the perfect cube of 3q plus 2 whole cube. That is, we can use the formula of a plus b whole cube. That is, a plus b's whole cube is nothing but a cube plus b cube plus 3a square b plus 3ab square. This is the formula that can be brought into the scene while finding out the perfect cube. So let us use this, a being 3q, b being 2. So it's going to be a cube, that is 27q cube, plus b cube, that is 2 cube, that is 8, plus 3a square b, that is 3, into a square is 9q square, b is 2, plus 3ab square, that is 3, into a value is 3q, into b square is going to be 4. That is, if we sum it up together, this becomes 27q cube plus 8, plus this is going to be 27 into 2 54 q square, plus 2 into 3, 3 into 3 is 9, 4 is 36 q. So this is the n cube expression. When he says when the n cube is divided by 3, So let us divide the n cube by 3 and try to find out the remainder. 27 cube plus 8 plus 54 q square plus 36 q. When they are divided by 3, each term can be divided individually by 3 to give the remainder. So the first term will give the remainder as 0 because 27 is completely divisible by 3. Next term 8 by 3. If we divide 8 by 3, the remainder comes out to be 2. Next term is 54 q square by 3. Clearly 54 is completely divisible by 3. So again the remainder will be 0. Then 36q. So if we divide 36 by 3, the remainder 36 is again completely divisible by 3. So remainder will be again 0. So if you add all those remainder, the ultimate remainder comes out to be 2 itself. So that is going to be our answer. The remainder will always be for n cube will be 2. That is option number C. Now he says a number n, capital N, is a positive three-digit number. If x is in its hundreds place and y is in its unit place, then the number n minus 100xy is always divisible by what? Okay, so let us try to solve it. He says number n is a positive three-digit number. So clearly he says x is in its hundred place. So the hundredth digit they have given out to be as x. What about the unit place? The unit place digit that has been given as unit digit is given as y. Okay, so only the 10 digit has been left out. So let us assume the 10 digit. Let's say the 10th digit that is not being given, we are assuming that the 10 digit is z, let's say. Now we can make the number number of three digit number is made in this way: 100 times the 100th digit number, 100 times the 100 digit, plus 10 times the 10th digit, plus the unit digit. This is how a number of three digit can be made using the digits. Let us try to solve it. So 100 digit we had assumed to be x, so it's going to be 100x, plus 10 digit we had assumed to be z, so it is 10 10z, plus unit digit is given as x, so it's going to be 10x. So this is our number. Unit digit is x, 100 digit is x, that is unit digit is y. Unit digit is y, so it has to be y here. So this is what is our number there: 100x plus 10z plus y. Now he's saying then uh, by using this, and this is going to be the number. So uh, we have to find out whether this number, then the number n minus 100 minus xy is always divisible by what. Okay, so that we have already made the number. If we try to transform the number to give away the value z, then n minus 100x minus y is always equal to 10z. We have no idea about z, so we can eliminate z. Now this 10 can be brought on the other side, so we can write like n minus 100x minus y by 10 is equal to z. That's what we get. So now look at the numerator of this particular term: n minus 100 minus n minus 100x minus y. That's what he was talking about here: n minus 100x minus y, rather n minus 100x minus y is the expression, is divisible by what? So clearly we can see it is getting divisible by 10, and we are getting a single digit z here. Why we can say that this is z is a single digit? Because assume the 10 digit to be z only. So it can always be a whole number, it cannot be a fractional number. And when by dividing something you're getting a complete whole number, that is, the number is getting completely divisible. So this numerator is completely divisible by 10, we can say that. So the right answer is the number n minus 100x minus y is always divisible by 10, option number C. Now, the product of three consecutive numbers is 3360. What is the least number? Okay. So, in this case, we have to assume the numbers. Let us assume the numbers like that so that we can easily able to do the product part. So, the numbers can be assumed as x plus 1 and x plus 2, but their product part will be difficult to find out, will be lengthy to find out. So, we'll assume the numbers to be x, x minus 1, and x plus 1. These are the numbers: x, x minus 1, and x plus 1. These are the numbers. Or now he's asking for product of three consecutive numbers. So these are the consecutive number. Obviously x minus 1 will be the first one, x will be the second one, this will be the first one, x will be the second one, and x plus 1 will be the third one to become consecutive numbers. He says the product of them is 3360. So let us do the product. X minus 1 multiplied by x plus 1 is actually equal to 3360. If you multiply that together, a minus b, a plus b is always x square minus 1. So it's x into x square minus 1 is equal to 3360. Now, this is the expression that we have. Now we have two choices. Rather, we can make an equation in terms of x cube. So the equation can be made like x cube minus x is equal to 3360, and then we can make it like x cube minus x minus 330 equal to 0, and then we are supposed to solve this equation, which again will have to go by hit and trial method because this is a 3 power equation. The next option that we have is we can do the hit and trial in this equation only. Okay, by assuming any value of x that is given in the options, we can try hit and trial. So let us do the hit and trial by seeing the options in the question. Okay, so let's have any value of, let's keep any value of x. Okay, so let's say the x value is 15. Among these we can pick, he's asking for the least number, so let's start with 14. So if the least number is 14, that is x minus 1 is 14, then x will be obviously 15. We have assumed x to be 15, x minus 1 to be 14. Then the largest number will be x plus 1, that is 16. So we have to just check whether this set of number with x equal to 15 is satisfying this equation or not. If x equal to 15 is satisfying this equation, that means the x value 15 is taken right. So let us try to put this 15 into the equation. If we do this, this is going to be 15 into 15 square minus 1 has to be coming as 3360. Let us do that. It is going to be 15 square is 225 minus 1 has to come as 3360. So if we solve this together, yes, on the right hand side we receive what? We receive 3375 minus 15, and that is nothing but 3360 only. So we can clearly say that by putting the value of x as 15, the equation is getting satisfied. That means the x value is 15. X value had to be the second number. X value had to be the second number. First number should be 14 and the largest number should be 16. He has asked for the least number. So clearly the option number B is right. X value least number is 14. Now, when the digits of the two digits number are interchanged, the number so obtained is less than the original number by 54. If in the original number the digit at the unit place is 1/4 of the digit at the 10 place, find the original number. So what we're going to do in this particular question, he has given a connection between the unit digit and 10 digit. He says unit place, the digit at the unit place is 1/4 of the digit at 10 place. So we know the connection. So we can assume any digit first, and then we can, using this connection, we can find out the other one. Okay, so by doing that, we will be able to find out the unit digit and the 10 digit in a single variable form, and by knowing them we can actually generate the number. Okay, and why when we will able to generate the number, we can obviously relate to the condition given here, number so obtained is less than the original number by 54. So let us begin with assuming any of the digits. He says unit place is 1/4 of the digit at 10 place. So let's say the uh, unit digit place number is, let's say the unit digit is x. Unit digit number has to be 1/4 of the tens place number. So 10 digit should be 4 times the unit digit. Okay, so 10 digit becomes 4x. See, the unit digit is still 1/4 of the 10 digits. So the connection is established. Now, how we can make the number? Number is always made by 10 times the 10th digit number plus the unit digit. This is how the number is made. So let us do it. 10 times the 10 digit number is 4x. So it's going to be 10 into 4x plus the unit digit is x. Okay, which makes it 40x, which makes it 40x plus x, that is nothing but 41x. Okay, so this is the number we can represent 41x. Now he says the number so obtained is less than the original number when the digits of the two digit number are interchanged. So we are supposed to find out the interchange number also, that is the reverse number also. So in the reverse number, 10 digit becomes a unit digit and unit digit becomes the 10 digit. So the connection is completely reversed. Now 10 times of the 10 digit will be 10 times the x plus the unit digit now will be 4x. So this will be the new number. If we solve this is coming out to be 10x plus 4x is simply 14x. So reverse number can be represented by 14x. Original number can be represented by 41x. Then he says the connection is by interchanging the number so obtained, that is this 14x is less than the original number by 54. Original number is 41x is less than by 54. So the 41x minus 54 is equal to 14x. So this is what is the equation that we are supposed to solve. If we solve this together, then we can find it out as 41x minus 14x is nothing but 27x is equal to 54, which gives the x value as 2. Using the x value of 2, you can find out any number he has asked for. He had asked for find the original number. The original number was nothing but 41x. So we are just supposed to multiply 41 into 2. If we do that, the number will be there. That is 41 into 2 is 82. So the right answer, the original number is nothing but 82, which is available in option number D. Now, he says the numerator and denominator of a fraction are in the ratio 2:3. If 6 is subtracted from the numerator, the result is a fraction that has a value 2 by 3 of the original fraction. What is the numerator of the original fraction? So in this case, we are not supposed to make the numerator as x and assume the denominator as y. Why we cannot do that? Why we are not supposed to do that? Because he has already given a connection between numerator and denominator. So when the connection between numerator and denominator is not given, then only we do like that, x and y. Here he says numerator and denominator fraction are in the ratio 2:3. So we can clearly make the fraction and then try to do it. Okay, so numerator is to denominator is in the ratio 2:3. So let's say the numerator is 2x and the denominator is 3x, and this is what is the fraction in front of us. Okay, he says numerator of 2:3. Now the next condition he says is if 6 is subtracted from the numerator. So let us subtract 6 from the numerator. So it's going to be 2x minus 6 divided by the denominator remains as it is 3x. What will happen? He says the result. So this is what is the result. The result is a fraction that has a value 2 by 3 of the original. So result has a fraction that is 2 by 3 of the original fraction. Okay, and what was the original fraction? Original fraction was simply 2x by 3x or 2 by 3. So the equation becomes 2x minus 6 by 3x is nothing but 2 by 3 of the 2 by 3 or 2x by 3x. Then x can be cancelled out. So now we can solve this particular expression for finding out the value of x. Obviously, these two x gets cancelled. This 3 can be cut by this 3. So we are left out with 2x 2x minus 6 over x is equal to 4 by 3. If we do the cross multiplication, we can find out, right, 6x minus 18 is equal to 4x. Okay, if we solve for x, 6x minus 4x is 2x. So x value comes out to be 18 by 2. That is nothing but 9. Okay, with x value as 9, we can find out anything. He's asking for the numerator of the original fraction. Numerator of the original fraction we had made to be 2x. So the numerator of the original fraction is nothing but 2 into 9. That is nothing but 18. So that is the right answer. Option number C is the right answer.